Is light really just energy? We often hear that light is pure energy. This statement, while seemingly intuitive, misses a crucial part of the story. Light is brimming with characteristics beyond just energy, making it a far more fascinating phenomenon than we might initially realize. To truly grasp the nature of light, we must delve into the realm of photons, the fundamental particles that compose this ethereal entity. Each photon zips through space at the speed of light. It behaves both as a wave and a particle, known as wave-particle duality. This duality enables photons to exhibit fascinating behaviors. Each photon carries intrinsic properties that dictate its behavior and interactions. These properties are measurable quantities used to study and manipulate light. Let's start with wavelength and frequency. Shorter wavelengths correspond to higher frequencies. Wavelength determines color, from deep reds to energetic violets. But there's more to a photon than meets the eye. It also carries momentum, a measure of its motion. Photons always spin with the same magnitude, influencing their interaction with matter. The energy of a photon is directly proportional to its frequency. Higher frequency means higher energy. This is why ultraviolet light, with its higher frequency, carries more energy than visible light and can cause sunburns. However, to say that light is just energy is like describing a symphony by only mentioning the volume. It ignores the melody, the harmony, the rhythm, all the elements that make a piece of music truly captivating. Similarly, focusing solely on a photon's energy neglects its other fascinating characteristics. Its wavelength determines its color, its momentum allows it to exert pressure, and its spin influences its interactions with matter. Unlike many other fundamental particles, photons lack certain properties, and these absences are just as telling as their presences. For instance, photons have no electric charge. This explains why light doesn't bend when passing through electric fields, unlike electrons, which carry a negative charge. Photons also lack mass. This is why they can travel at the speed of light, the cosmic speed limit that nothing with mass can attain. The fact that photons lack mass might lead some to believe they are pure energy. However, this is a misconception. While energy is a fundamental property of photons, it doesn't define their entire existence. Think of a thought. It has no mass, but it's not pure energy either. It carries information, evokes emotions, and can even inspire action. Similarly, photons, despite being massless, are far from simplistic entities. Their lack of mass allows them to travel at the universe's speed limit, but it doesn't strip them of their other remarkable properties. The absence of mass simply means that photons experience the universe in a fundamentally different way than massive particles. Understanding and harnessing the various properties of light has revolutionized fields ranging from communication to medicine. Consider cameras. They capture images by using lenses to focus light onto a sensor. The sensor then converts the energy of incoming photons into electrical signals, which are processed to create a digital image. But cameras rely on more than just the energy of light. The wavelength of light determines its color, and cameras use filters to capture specific wavelengths, allowing for color photography. Our own eyes are sophisticated biological cameras that exploit the wave-particle duality of light. The retina at the back of our eyes is covered in photoreceptor cells that contain light-sensitive pigments. When a photon strikes a pigment molecule, its energy is absorbed, triggering a chain of chemical reactions that ultimately send a signal to the brain, allowing us to see. These are just a few examples of how our understanding of light's properties has led to technological advancements. Light is far more than just pure energy. It's a symphony of photons, each a tiny packet of energy carrying a unique set of properties that dictate its behavior and interactions with the universe. From its wave-particle duality to its remarkable properties like wavelength, momentum, and spin, light reveals a universe far more intricate and fascinating than we might initially perceive.